Imagine an aeroplane which is about to take off. Its velocity at the ground was 5, but when it takes off, its velocity becomes 3 plus 4i, 3 being the horizontal velocity and 4 which is a representative of its vertical velocity. Care has to be taken that 3 and 4 are not to be added together. This happens in complex numbers. Complex numbers come whenever a parent influence or a parent force gets divided into two parts. One part is called as the real and the other as the imaginary part. The net velocity in this case is the square root of the imaginary part square and the real part square, and the angle of takeoff will be equal to tan inverse of 4 divided by 3, that is 4 divided by imaginary upon real part. Whenever an object and influence divides itself due to the perception of it, that time also complex numbers come into the picture. If you look at a slide from the front, you will see one part, and if you look at from another angle, you will see another part. Look at the cylinder also. From one angle it looks like a circle, another angle it looks like a rectangle. So imaginary numbers are not a product of your imagination, they are actually just as real. Whenever a force or an influence gets divided into two, when they split into two, these two components are called as real and imaginary parts. One part, which is the parallel influence, is called as the real part, and the other part, which is an influence perpendicular to a reference surface, is called as the imaginary part. So complex numbers, real numbers, have a reason to come into mathematics. Now just look at the image that will be shown. The shadow below is the real part and the shadow aside is the imaginary part. I raised to 1 in complex numbers means a rotation by 90 degree, I raised to 2 a rotation by 180 degree, I raised to 3 a rotation by 270 degree, and I raised to 4 will be a...
What if there's an ebook where at least the building blocks of math can be visualized with the help of intuitive images like the way you're seeing on the screen? What if sine theta can be visualized as a measure of how perpendicular two forces or influences are? In other words, sine theta comes into math whenever two forces are such that they produce maximum impact when acting perpendicular to each other. What if you can visualize the actual reason of why sine theta equals to opposite side upon hypotenuse with the help of an animated example as you are seeing on a screen? Now, just as sine was a measure of how much perpendicular two forces are, what if you are told that cos is a measure of how much parallel two forces or influences are? Ever wondered why cos 0 is always maximum? The more aligned, the more parallel two forces are, the greater the value of cos theta. Cos, in fact, comes into math when two forces or influences are such that they produce maximum impact when acting parallel to each other. What if complex numbers can be visualized with the help of animations like you are seeing on the screen? I raised to 1 a rotation by 90 degrees, I raised to 2 a rotation by 180 degrees, I raised to 3 a rotation by 270 degrees, and I raised to 4 a full 360 degree rotation. What if someone tells you that complex numbers comes into math when one influence splits into two or more branches either due to rotation or some other reason? One branch is called as the real part, the other as the imaginary part. What if an ebook tells you that complex conjugates are nothing but vertically opposite mirror images of each other? 3 plus 4i is like climbing the uphill of a slope, and 3 minus 4i like going downhill. What if the formula of logarithms can be visualized as the log of every effect gives you the cause of that effect on the other end. The base of log is nothing but the rate at which the cause and effect relationship is changing. What if in integration or calculus dx and dy means keep adding along the x and the y axis respectively? dr would mean keep adding along increasing radius, dh along increasing height, d theta along a vertically curved path, and d psi means keep adding along a horizontally curved path. What if integration and differentiation can be seen as evil twins of each other, that is, reverse processes of each other? Integration, a process of addition; differentiation, a process of subtraction or taking away. Divergence can be visualized as the rate of change of the field as you move away from the source of the field in a three-dimensional setup. Curl, on the other hand, can be seen as the ability of a field to try to rotate you or spin you in a certain direction. I, J, and K being the three different planes of rotation, three different dimensions in which rotation can take place. What if you are told that the diagonal of a matrix is the axis around which things rotate, and that the transpose of a matrix is the entire matrix or the object that it represents rotated by 180 degree about the diagonal as an axis, and that the transpose of a matrix will be the entire matrix rotated by 360 degrees. Visualizing math 1 is the result of years of hard work done into the research of the meaning behind these equations. What these equations mean are explained with the help of simple and down-to-earth examples, animations, and analogies so that everyone can understand. Everyone is a beginner at some point, and visualizing math is dedicated to beginners or even advanced users who wish to visualize things in order to understand. It has very little definitions and more of examples and analogies. The link to the ebook is given in the description. It is also available on Amazon as a paperback, the link to which is once again given in the description.